Hello friends, this is lesson 18 of NLP, Natural Language Processing. In today's lesson, we are going to cover the following topics. First, we'll be discussing about deep learning in neural network, and then we'll see TensorFlow in Keros Python libraries. Then we'll see training a multi-layer perceptrons, and then we'll talk about deep learning models, and we'll give some examples for them. Now let's start with the first topic and understand what is deep learning itself. So deep learning actually describes the large family of neural network architectures that contain multiple interacting hidden layers. So from this definition, you can easily understand that deep learning is actually a family of neural network with multiple neurons and hidden layers. So we can say that deep learning is a subfield of machine learning which is inspired by the structure and function of brain. So you know that brain is a complex organ in human being body, so that contains multiple or we can say in terms of thousands and millions of neurons, and they are working together and then perform a function, right? So the logic is taken from there, and that logic is implemented, and it is called deep learning. Now let's see what is neural network itself. So neural network, a short definition, we can say that deep learning algorithms. In short, we can say actually neural networks are nothing but deep learning algorithms. Or we can say neural networks, or also we can call it as an artificial neural network, is a collection of artificial neurons where each neuron looks at the output of the other neurons to feed into it. So here, and brain neurons, they are biological neurons, but here we have artificial neurons, and these neurons are working together and they have created a network. So that is why it's called artificial neural network. And actually how they are working, one network is taking the output of the previous network as an input, and after performing an action on that or performing an operation on the data, and that data will be provided for the next neuron as an input. So the output of the previous network will be the input for the next neuron. So that is the logic. Here it says that it looks at the output of the other neurons to feed into it. Here we have the simplest neural network with a single neuron, and n number of inputs is called perceptron. So perceptron is also a neural network with a single neuron. It has multiple inputs, maybe like 2, 3, 4, 5 like that inputs it may have, but it has only a single neuron. That network is called as perceptron. One thing which is very much important, friends, this you have to remember, is neural networks do not process raw data like text files, CSV files, etc. What we have to do, the first stage we have to complete, and that is like normalization or pre-processing, we can call it. If it is text, we have to vectorize it and normalize it. If it is numbers, again we have to remove all the outliers. It should be cleaned, right? The data should be, the first step pre-processing should be already done, then it is ready to apply it on neural networks. This is much important, friends, this you have to remember. Next, what do we have? The two common libraries which are used for deep learning, and they are called TensorFlow and Keros in Python. Now let's see first what is TensorFlow library. It is an open source Python library which performs computations involving in tensors. It is actually developed by Google. Now let's see what is this tensor. Tensors are nothing but a single or multi-dimensional arrays of data passed to each layer of nodes. This is called tensors. It is like a list of values, maybe like a single array or multi-dimensional array. It is full of data and passed to the layers of the nodes. Then we have the Keros library. Keros library is also an open source Python library which is used, or we can say deep learning or neural network API, which is capable of running on the top of TensorFlow. So actually this Keros is a library, open source Python library, which is running on the top of TensorFlow. It means while we are using Keros, first of all we have to install TensorFlow, because Keros is using or utilizing the functions of TensorFlow. So here in Keros supports two types of models. First type of model is called sequential model API, and the second one is called functional model API. Now if you think about this one, sequential, the name itself indicates that it is a linear stack of layers, and the most common one is dense layer, right? So it is a stack of layers, and the common one which we use the most is called dense layer. So here when we talk about functional models, in functional models it is the same as sequential models, but with advanced models, algorithms, and complex network architectures. Now let's talk about here the third topic in C, training a multi-layer perceptron. We did understand that what is perceptron. Perceptron is a neural network with a single neuron and n number of binary inputs. So that is called perceptron. But what we have here, we have multi-layer perceptron. It means we have more than one neuron, and they are combined together and working as a neural network. So multi-layer perceptrons, or it is also called as a feed-forward artificial neural network, consist of multiple neurons. So the name itself indicates multiple neurons that are organized in layers. If it has only a single neuron, that is called perceptron, but since the name itself indicates here multi-layer perceptrons, it means it is a collection of neurons together, right? Multi-layer perceptrons or networks can be implemented using Keros library. So if you are implementing this multi-layer perceptrons, we have to be using Keros library. And then we have deep learning models. There are some common models which are used here. The first model is called recurrent neural networks, or RNN, and then we have long short-term memory networks, LSTM, and then we have recursive neural tensor networks, or RNTN, and then we have convolutional neural networks. So each and every algorithm or model has its own features and we can say characteristics. They are different from each other. Let's talk about the last one, how it is used or for what purpose we can use that. CNNs. So these CNNs are highly effective for modeling image data and performing tasks like classification and summarization, right? So like this, each and every model has its own specification, or we can say the features. Now let's start and see all these things practically, friends, then you can better understand here. So the first thing, I have to import these two libraries, NumPy and Pandas. So I'm executing this part, and then we talked about deep learning, and we said deep learning is actually describes the large family of neural network architectures that contains multiple and interacting hidden layers. It means multiple neurons and multiple hidden layers, or we can say it is a subfield of machine learning which is inspired by the structure and function of human brain. The logic is taken from there like that. And then we have talked about neural network, and we said neural network or artificial neural network is a collection of artificial neurons where each neuron looks at the output of the other neurons to feed into it. And so here we talked about perceptrons, and we said perceptron is a neural network with only one neuron and n number of inputs. So here we have, you can easily understand from this, so it computes the weight sum of its inputs and fires if the weight sum is 0 or greater than that, right? So here this figure is taken for logistic regression. The logic here, it is implemented, it has a single neuron. If the value is greater than, here this value 0.5. If it is greater than 0.5, it will be firing 1. If it is less than that, it will fire 0, right? So here we have number of inputs, and these are called the weights. Here we have W0, W1 up to Wn. These are called the weights. Actually, these are numbers expressing the importance of respective inputs to the output, right? So here we have to find the sum of this. It means the inputs into the weight, these two will be dot product, and then all of them will be summed together, and that is fed to this neural network. A neural network will be deciding whether it is greater than 0.5 or lesser than that. If it is fire 1, if it is lesser than that, it will be firing 0, right? So here this is the formula. If x is equal to 1 by 1 plus e to the power of minus lambda into x. And now here let's see how to create a single neural network with only one neuron, and that's called Sigmoid function. Here I have created a class called Perceptron, and we need the weights and bias for that. So I will be, and then I have a function called Sigmoid function, and you know that this Sigmoid function requires a single value called x, and that 1 divided by 1 plus e to the power of minus lambda into x, that we have to implement here. This is equal to 1 divided by 1 plus np from numpy. I am taking e, right? E is a constant value, so e to the power of minus x. Here it will be returning 1 if 0.5, otherwise it will be returning 0, right? Then here the actual operations will be performed as I said before. Weight and inputs will be dot producted, and after that it should be added with bias, and then we have to feed that to our Sigmoid function, and then the Sigmoid function will be taking decision whether it is greater than 1 or lesser. Greater than 0.5, it will be returning 1. If it is less than that, it will be returning 0. Let me execute this part and see here. Now this is the weight 2 into, and this one is the bias. Then I am creating the object of my class by passing these two to my constructor, right? The object will be created, and then I say x is equal to this one. This is the vector, and then I am calling this function and passing the value of x. You are getting it is 1 because the value is greater than how much? 0.5. Let me show you that whether it is really greater than or not. I will directly return s, not I am not giving the condition. Here you will see now. See, the value is how much? 0.999. That is why it is returning 1, right? As we put like this. Now this time it is returning 1. But if it is lesser than 0.5, it will be returning 0. For example, let me put here minus 10, and then we will see, yeah, it is returning how much? 0, because what is the value? It is lesser than 0.5. Yeah, you see 0.0024, that is lesser than this value 0.5. That is why it is returning the value 0 for us. Now you see 0. So I hope you understood how this Sigmoid function is working, and it is a simple example of neural network. Logic is implemented in logistic regression model, and this one you can better understand. Here we have 0.5. If the value is greater than that, Sigmoid function will be firing the value 1. If it is lesser than that, it will be firing 0. Now let's see here, we'll use Tensorflow and Keros Python libraries, and we said they are both open source libraries for deep learning. And we then talked about Keros. It supports two types of models, sequential functional models, and how to create a neural network with multiple perceptrons. It means not a single perceptron as we did before, we will be having multiple perceptrons, or we can say neurons. So multi-layer or feed forward artificial neural networks consist of multiple neurons that are organized in layers, right? For that we'll be considering our data from this file email.txt. so I will be using pandas library, and then I say PD, which is taken from pandas, and reading the data, and at the same time I will drop the null values, and here I will be displaying it like this. So we have these are the labels, two labels we have, ham and spam, and these are the messages or features we can call them. And now what I'm going to do here, the first step, I'm just mapping these values with dummy variables. So ham will be assigned as 0 and spam will be assigned as 1, and then I'm calling this function map, and these two values will be mapped with 0 and 1 like this. Now instead of ham and spam, what do we have? For ham we have 0 and for spam we have 1, right? Now as we mentioned before, neural networks directly will not work with unprocessed data or raw data. That's why we have to process the data. It means we have to normalize the data, and we have to vectorize or transform the data if it is text. That is why first of all I am splitting the data into training and testing data by using this function train underscore test underscore split, and this one is taken from model underscore selection. Then here I will be giving, these are the features and these are the labels, right? And text size is also taken, test size, it is equal to 20% goes for testing and 80% goes for training. Now here I am initiating here my vectorizer TF IDF. This you know that we have already discussed in previous lectures, and then I am transforming the data into dense array here, and again I am transforming x underscore test also to dense array, and they are transformed into document term matrices. And then here what I am going to do, I will be taking the number of features. What are the number of features? I say x underscore train. From train data I will be taking shape like 1, because 0 is nothing but the number of features, the number of rows, and these are the number of columns. Let me show you here, then you can better understand, friends. See here, what do we have? These are called the number of rows, and these are called the number of features or predictors we can say, or they are also called as a predictors, features, or inputs you can call it. So here if I put 0, it will be taking the number of what? Rows. No, I don't want that, because I want only the number of columns, because the number of columns are nothing but the number of features for us. That's why I have put here 1 to take this value, not this value. I hope you understood all these things. Now what I'm going to do here, we will be using Keros sequential model, and here I say from Keros.models you import sequential, and then we have to use the layers, right? Then I'm creating here or instantiating the sequential model. The model is created, and then I'm calling another function called add, and then I say layers dot dense, because we say dense layer is nothing but it is the regular fully connected layer. In Keros it is nothing but a stack of linear data we can say, or it is the same as like array, right? And then we have specified here 10. So what is this 10? 10 is the number of nodes. We have 10 nodes here. In hidden layers we will be having 10 nodes like this, 10. It will maybe like this, we have 10 hidden layers in first phase, and then we have input dimensional is equal to input dimensional. So this input dimensional actually comes from here. Here I have said input dimension is equal to how much? This one, the number of features. I mean these values, right? So then I have specified here activation function. In that activation function, in first phase it is equal to reload. So what is activation function? Actually activation function, or it is also called as a step function here. This one is called activation function, friends, in neural network, right? Here this one is Sigmoid function, but if we have multiple neurons, so then the inputs into its weight will be fed to the neuron. That first neuron is called as the activation function. So the result of that will be fed to another one like that. So then the last one is also like here we have this one is Sigmoid function, and this is also called as a step function or activation function, we can call it. So here I have said activation function is equal to ReLO. What do you mean by this ReLO? It is taken from a rectified linear unit, and that is equal to maximum of 0 and x. Why we have put this? Because we are just removing the complexity of model by not considering the minus values, right? So here if the number x is lesser than 0, like it may be like minus number, so in that time it will be returning the value 0. If it is greater than that, it will be returning the value of x. So it means we are just avoiding the minus numbers and reducing the complexity of our model. And then we have again used model.add. In here again dense layer is used, but here we have only one node, and activation function is equal to Sigmoid. It means the last one, this one. So we have only one node, and here activation function should be Sigmoid. Sigmoid means implementation of this formula. I hope you understood this. If it is greater than 0.5, it will be returning 1. If it is lesser than that, it will be returning 0, right? And then one thing else we have to remember, that is model.compile, actually configuring learning process using, we have to use this one for configuring learning process. And there we have some attributes, we have to put the values like that. Optimizer is equal to Adam. So this Adam is actually, it is taken from adaptive moment estimation, we can say. It is actually used to update the neural network weights iteratively based in training data. The weights will be automatically updated. And then we have loss is equal to binary cross entropy. Here this loss can take two values here. It depends on the predictors, whether it is binary or it is categorical data. It means like here in this case for us it is binary, that's why I have put here binary, because we have only two values. The labels are 0 and 1, ham and spam. But if we have categorical values, like what do we have, like qualification, if you remember, there we have bachelor, master, PhD. So there the values are more than two values. Instead of binary, in that time you have to use here categorical underscore cross entropy. So in this case, since we have only two values, I have used this one, binary cross entropy, right, 0 and 1. And then since we are classifying, in classification what we have to be considering, model performance will be evaluated seeing by its accuracy. That is why I said matrix is equal to accuracy, and we will see the accuracy of our model, how the model performs. Let me execute this part. I hope you understood all these things, friends. And then let's see here, training the model. So while training neural network, in that time we have to use the function called fit. This function will be calling, and you say model.fit, and then you provide the training data here. And then we have here something called epochs, and then we have batch size and variables. So what do you mean by this epoch? Epoch is actually, friends, training a neural network is an iterative process. It means it will be iteratively running, it will not stop. If you want to stop it, so you have to mention how many iterations you want, right? Like whether you want to 10 iterations or 100 iterations. But if you're not putting or not giving the values here, it will be automatically, it will be like iteratively executing your program, right? It will not stop just running like that. So here then we have batch size. It means the number of samples, how many samples you will be considering in each epoch, right? And first epoch, 100 sample size I want, and again like that in second epoch, third epoch, like that it goes, and 100 sample size will be considered. And then we have variables. It is taking two values, either 0 or 1, or we can say true and false. If it is true, so it will be showing you or displaying you animated progress in the form of a line. If it is 0, so it will not show that. I will show you both how it is working. Let me execute. Then we have here the summary. This function will be returning the summary of what we have done here. it is taking some time. So it depends on the processor and also the size of the data what you have, so it will be taking time, and then you will see the result after that. And then model performance. So model performance, here what we are going to do, will be calling a function called evaluate, and then we can calculate the accuracy of the model, training model accuracy for training data and accuracy for testing data, that we can see. Now see friends, this is the result what we get. So see the first layer, how many nodes we had? 10. So 10, this one we have, and then 10 into this number, right? So how many parameters do we have here? We have these number, this one, right? This into 10, so we get this one. And then what do we have to do? The result of that will be, lastly again we have another dense layer. In there we had only one node, right? So 1 plus this 10, it becomes 11, right? So these are this you have to remember. What do we have next here? We'll be saying the model performance like this. So accuracy will be printed, and then we have training accuracy, and then we have here the testing accuracy. If I hide this, let me cut it. This one is training accuracy. It is actually equal to 100%, we can say 0.999, and this one is called loss. Maybe some things, or it is not like the data is not cleaned, it is having some problems. We have to normalize the data. If you remember in previous lectures, we have to convert them all to lowercase, tokenizations, all those things. Then again we will be having the performance goes up. But here it is, that's why it is less than, it is not 100%. Then what do we have? If you want to see the testing accuracy, I will be running again, and this is called the testing accuracy, and that is equal to 99%, and this one is the loss, right? Now let's see here. We'll do some predictions. I will be passing some data to my function called prediction, and then I will call this one predict, right, from model.predict, and passing this message to that. And after that you will see the returning value, whether it is greater than or equal to 0.5. If it is greater than this value, it will be returning spam, because in spam, if you remember here, we said the label for spam is how much? It is 1, and 0 is the label for ham. That is why I say if it is greater than that value 0.5, it will be returning spam. If it is lesser than that, it will be returning ham. It makes you keep the spot, and I am passing these two messages. Let's see how the model returns and what are the values. So the first one, this one, it is returning here, it is spam, but for this one it is saying it is ham. Instead of that, if you are returning the values, not these labels, it will be showing you some numbers greater than 0.5. It may be greater than that, that's why it's coming spam. And for this one ham, the value is obviously lesser than this 0.5, that is why it's saying ham. So I hope you understood all these things, friends. We talked about deep learning, we talked about neural network, and then we implemented some neural networks. The first neural network, which is called the Perceptron, and Perceptron, we said it is a neural network with a single neuron, and we gave an example of logistic regression for that. And then we talked about TensorFlow and Keros, and then we saw how to train a multi-layer perceptrons, and we did all those things, and we talked about these models. I hope you understood all these things, friends. Thank you.